Hello, everyone. My name is Justin. I'm the tech lead on the meeting recordings team on the Loom product of Atlassian. And I'm here to talk to you about a challenging type of software engineering that my team has come intimately familiar with in the last year. Before I put a definition to it, I want to start over with a hypothetical situation that might help illustrate it. So let's say you're on the team that owns a service called Service X. One morning, your phone goes off with an alert that the system is down. So you roll out of bed and you open your laptop to take a better look. It turns out Service X relies upon dependency Y, which seems to be not working all of a sudden. You start browsing the recent Git history of Service X. There haven't been any suspicious commits lately. Then you review the code for the dependency Y integration, and it's hitting an undocumented private API that's requesting JSON, but now it's returning HTML with a 500. So it also turns out that it's ancient in origin, this integration. It hasn't been touched in years. And even worse, it's unmaintained and has no clear ownership. So a wave of futility comes over you as you feel like you must now start looking for a needle in the haystack. And this is when you now must begin escape room software engineering. So to put a definition to it, I'm going to define it as escape room software engineering is building, maintaining, and debugging software that is forced to interact with external systems in an opaque and unofficially supported manner. It is not an aspirational first choice when deciding how to build systems. It's a pragmatic methodology for minimizing pain in special scenarios. And finally, escape room software engineering best practices are often just good overall software engineering habits, where the value is greatly amplified when escaping the room is required. So we've come up with different names for this sort of thing over the last year, but I want to give credit to my teammate Tatiana for the one coining the term escape room software engineering. Out of all the options, I think it best describes the challenge of fighting against the black box of the system. So before we get into some case studies, I want to run through a quick overview of our general architecture, starting out with our development timeline. So I came to Atlassian through an acquisition of a startup called Rewatch in late August 2024, where we specialized in recording meetings on users' calendars. So immediately after getting acquired, we started building these features into Loom. Some things were ported and some things were built from scratch. At this time, none of the video meeting platforms offered a real-time API for consuming media streams. They did offer official APIs where we could ingest the media after the meeting had completed. But one of the killer features of Loom is that when recording stops, you immediately have a URL for the Loom and it's playable within seconds. Also, we had features that needed the Loom note taker to be present in the meeting so that you can interact with it. So it needed the context of the live transcript of what was happening. So using a post-meeting API was never really seriously considered. So that led us to go down the same path that our competitors did, which is using browser automation. So 2 months after we started, we released an internal beta within Atlassian. And then 4 months later, we released it to everyone. And then later that summer, both Google and Zoom released APIs in developer preview for consuming real-time media streams. And we're actually working on adopting those right now. And once that migration is complete, it'll negate a lot of the challenges that I'm going to be talking about here. So moving on to the general architecture, the Loom Note Taker is a containerized app that is spun up on demand in a Kubernetes cluster. And we have a microservice called Rewatch that handles the scheduling and spawning of the note-taking bots. Inside the bot containers, we run a Node.js app and Chromium. The Node.js app is able to drive Chromium using the Playwright library. Playwright navigates to the meeting URL and fills out the joining meeting form just as a guest user would on behalf of the one who's recording in Loom. Once the note taker is in the meeting, we request a stream of the browser's tab that is rendering the meeting, and we send that to the off-screen page of our Chrome extension, which is a stable environment that lives outside of the lifecycle of the video meeting page. The video stream segments are then processed and pushed up to our object store, which currently right now is S3. And then throughout the life cycle of the note taker, we send messages back and forth from the extension to the Node.js app using the Chrome runtime API. And we communicate with the bot in the video through internal APIs, for the rewatch and Loom services. So you'll see that there's a lot of lines here and components and communication layers, but ultimately everything here in blue is under under the domain of our control. But the video meeting itself, however, is a black box. We have very little visibility into how the video meeting web client is built and how their server works. And this is where the escape room software engineering comes into play. So I'm going to walk through two use cases we've encountered in last year. First one has to do with Google Meet. Starting in May last year, we started getting an increase of Google Meet bots that were erroring with a specific symptom. At a high level, what happens is the Google bot shows up and it joins the meeting, fills out the form, and then it waits for confirmation that it was let in, where it's looking for being able to see certain controls within the meeting and participants, and then it starts recording. But these bots were never starting to record. They would just sit and wait for 20 minutes, and they never transitioned to this join state. So then they would time out and bail with a cancellation code. When we looked at the timing pattern for this, we noticed that there was an increase in these cancellations during peak US working hours where the East and West Coast overlapped, always 20 minutes after the top of the hour or the half hour. So first we had Playwright take and upload screenshots to see what the bot saw when it decided to cancel after 20 minutes. And in these cases, what we saw was just the Google Workspace's homepage. So then we installed an event listener with Playwright on frame navigation, so we could catch right when we were redirected away, so we could cancel it then instead of waiting 20 minutes. And then we also added screenshots on an interval leading up to recording starting, so that if this happened, we could upload the last taken screenshot to see what the note taker saw prior to the redirection. And so what we saw there was a screen that looked like this, where presumably, which says that the call has ended, but presumably not all of these users, were putting meetings on their calendars that were in fact ended. So our initial guess was that we were hitting some sort of rate limiting behavior on Google's end. Most meetings take place at the top of an hour or half hour, so we're creating a sort of thundering herd of traffic every 30 minutes. Also, this was corroborated by the fact that the error rate was worse during these peak US working hours where the coasts crossed over. So we checked with our core networking team in Atlassian, and we verified that all of our traffic egressed through a single IP address per availability zone, which meant that all 1,000 plus Google bots that were coming out of these peak hours were coming through one of 3 IP addresses. Something that we added was capturing uncaught errors that happened within the video meeting webpage itself, and we logged those for inspection. And when we did that, we noticed that a 429 was happening. And immediately following that were more uncaught errors with some minified JS that was happening on the page. This occurred immediately prior to the note taker seeing that call has ended screen. So I downloaded the bundled and minified Google Meet client code. And luckily, because strings are minified, I could see that there was a disconnection error that was happening. So we installed a Playwright listener on page errors for 429s, and then we logged the URL and the response bodies for those. What we found was that this was coming from an internal Meet API. It seemed that because all of our bots were unauthenticated guest users coming from one of 3 IP addresses, Google is attributing all of our traffic as coming from one of 3 suspicious users. With this evidence in hand, we leveraged some internal contacts we had with Google, and through some triaging, we eventually set up a meeting to discuss the issue with the liaison to their networking team. We explained our theory, and they confirmed that that was exactly what was happening. But best of all, they gave us a friendly wink and a nod that it would be okay for us to pursue a way of diversifying our IP addresses to get around the issue for the time being, since we were already locked into adopting their new official API. So we went back to our core networking team, and they allocated us to do public subnet, and our infra team for Loom devised a way for our bots to check out IP addresses from a node pool. And immediately upon launching this change, all the unexpected redirects went away and the problem was solved. So now I'll jump into the other use case, which happened on Microsoft Teams. One day we started getting reports through support that Microsoft Teams meetings were getting recorded, but with no audio. But when we looked at the recordings, there were actual audio segments for these looms, but they were silent. Coincidentally, for an unrelated feature, we had recently just added support for silence detection in the bot. The way this works is we create an audio worklet processor that analyzes the audio of the media stream coming out of the browser's tab that we are providing to our Loom recording library. With it, we detect and report different lengths of silence durations. And sure enough, without any dependency or code changes, all of a sudden we started getting an uptick in silences being detected on Microsoft Teams. But frustratingly, it couldn't be readily reproducible. When we were trying to reproduce this, only about 1 in 10 bots would hit this issue. We are aware that Microsoft does some A/B redirection on their end to different team experiences, as they call it, but we're in the dark about what controls that mechanism and any future feature gating on their end. And the symptom didn't align with any of the experience detection code that we had in place. Worst of all for this incident is that the note taker wasn't trained to be aware that it wasn't receiving audio. So it would just sit there all meeting like normal, only to produce a Loom with no audio afterwards, which meant that there's no transcript, there's no recap emails, action items. There's no retroactive way to get the audio from that meeting. And you can't just get the participants to go and have the meeting again. So we called it an incident and I started debugging. First, I noticed I was able to reproduce the issue if I launched the bot locally on my computer and revoked my local microphone permissions in Chrome for testing prior to the joining. When I did this, it would produce a meeting recording with no audio and the permissions. And in this permission state, I got a join screen that looked like this. Then if I restored microphone access and did the process again, the join screen looked like this. Notice how the entire audio section is now enabled. So to help with gathering more information, I added logic to take an upload screenshot again, along with the page HTML when the bot made it to this part of the joining process. My testing thus far had been outside of Docker, but our production bots are based off of Docker images that we create. But in all of my Docker testing, I wasn't able to reproduce the issue. So we just had to wait until we got a report for one that aired. When it succeeded in Docker, it looked like this. But did you notice that there was the difference between the first one and the third one? It's very subtle, but you'll see that there's no slash through the output icon. Eventually, we got a new report of the issue through support, and sure enough, when we looked at the newly uploaded screenshots, but the one that failed, it also had a slash through the speaker icon. So I threw together a PR to detect this scenario so that if we saw this, immediately upon joining, it would post a chat message that there was an error with the audio and then leave instead of sitting there the whole meeting lying to the participants that it was successfully recording. But how could I detect the scenario? Well, when we inspected the HTML on the Teams client page, it wasn't ideal to work with. When comparing the relevant section variations, the DOM structure was identical. It had a bunch of auto-generated CSS class names that were the same, and then the area labels weren't differentiated between them. The only thing I could match against was the geometry of the path of the SVG itself. This is obviously a very ugly hack of a solution, but it worked, and it slowed down the bleeding while we could look into the actual fix. So far, we had identified that for some reason, Teams was no longer consistently providing the audio of the meeting to the Chrome tab that the bot was capturing the media stream of. So something was going wrong at the red X here. My hunch was that a newer, partially rolled out Teams update was making an assumption about the availability of our audio output device based on the availability of the mic stream and not providing audio in that case. The thing is, we do actually grant permission to these pages, access to the mic. The input device is just not connected to anything. Inside of our Docker file, we generate a Chromium preference file that we shove into the relevant location. And it works for the other video platforms, and it did for Teams until recently. So I started by computing the diff of my local Chrome for testing's JSON preferences file before and after I toggled the mic permission. And I copied over all of the Teams-based preferences in the version that we injected into the Docker container. This included computing and setting relative timestamps based upon the milliseconds since the Windows epoch, which is a different epoch than the Unix epoch, I learned. Then after rummaging around through the Chromium CLI flags, I found -- use fake device for media stream and its usage in the Chromium source code. When enabled, it creates a sample video and audio stream available at the microphone and camera sources. I noticed that when I built a Docker container, a Docker image with these changes, the audio section of the join screen suddenly became enabled and toggleable. So then I added some playwright automation to turn off the fake device so that the bot would enter the meeting as muted as it was before. And once the PR with these 3 changes landed in production, all instances of the no audio issue went away. So now that you have a sense of some of the real life escape room software engineering that our team has done, I wanted to share my 8 rules for escape room software engineering. The first rule is the very most important rule. Do not design and build systems that require escape room software engineering unless you absolutely have to. The nature of these challenges are stressful and time-consuming, which are especially unfun in an incident environment. You can't plan your work week around them happening or not, and your system will constantly be haunted by unknown unknowns that could manifest at any time. So always strive to use officially supported APIs when possible. And the second rule is the second most important rule. If you are forced to resort to escape room software engineering, seek to cultivate good relationships with the owners of the external systems. In our case, with the Google rate limiting, we were pretty sure of what was happening, but we didn't want to either spend the time building an infra-based solution for something that wouldn't work or do something that would tick off Google and sour the relationship. Luckily, in our case, there's a strong partnership between the companies, and we were able to leverage some internal context to set up that meeting. In our case, we were dealing with an external system owned by another company, but it's possible to run into similar challenges within one large company. Say there was some like boutique integration with a system in a distant quadrant. By establishing good relations with the owners of the other systems team, you might be able to influence them about what a more reliable official integration might look like. So the rest of these are just some good general software engineering best practices that have been particularly helpful for us managing these types of issues. Rule 3 is to define and enumerate all the things that can go wrong. Last quarter, we slowed down on feature work and made it a priority to improve reliability and debuggability. There's a lot of different ways a meeting bot could end up not recording, and at that time, our failure rate was around 6%. We'd frequently get reports along of why didn't the bot start recording, and support didn't readily have access to the clear debugging information to know exactly what happened. So we'd be forced to look at Datadog logs, screenshots, and try to make sense of what happened. After going through this process many times, we came to bucket the errors into 2 types, failures and cancellations. Failures are reserved for when a bot fails either due to a known internal issue or an unknown or unexpected external issue. A bot that is canceled, on the other hand, wasn't able to start recording for a known reason, and it's usually related to an external video platform setting or a user action, and it's something that's ultimately correctable. By going through this process, we now have 54 unique failure and cancellation codes, and it's been over a month since we've encountered a failure of the dedicated unknown type. So by being very strict about giving every error a code, we have much better visibility into what types of issues the bot ends up facing, and it revealed a bunch of edge cases that were fixable. And by going through this process, we were able to reduce our failure rate from around 6% to less than 0.1% today. Another nice part about having first-class error codes is that we're able to easily build custom notifications, such as emails, that can include unique instructions on how to fix that specific issue. And this helps empower the customers to self-correct problems before they feel the need to reach out to support. Rule number 4 is observability excellence is non-negotiable. When dealing with external systems, you aren't always aware of the schedules on which they're updated. Without a good paper trail, it can be very hard to deduce when and where and exactly why, like when things go wrong. PRs for new features and bug fixes should be verbose with logging within reason, obviously, but should mark all identified viable workflow checkpoints in a sequence towards success or failure. If a known unknown occurs, pinpoint exactly what information you need at that point to get unblocked. In our case, when driving Playwright, typically screenshots and capturing the state of the DOM helped, so we could automate our way out of it. And then obviously good metrics and logging is just foundational to building good debugging tools and creating monitors. One logging practice has been particularly helpful for us is attaching structured JSON, event JSON blobs containing UUID-based identifiers to all of our logs across services, which helps make it very easy to take a single GUID, throw it into a search, and be able to see a timeline across services of what happened. Rule 5 is to value and cherish the PIR action phase, which is the post-incident response phase. Regardless of how proactive you are, trying to preempt all potential issues, there's no way to know how black boxes work, so you're bound to run into unexpected ones. Once they become known, it makes this phase critical to take what's learned and adjust the system accordingly. It shouldn't just be a matter of checking off some compliance like box that this was done. It's a great opportunity to take all the knowledge and reevaluate how aspects of the system work to improve your observability. If the issue would have been caught by the customer, if the issue would have been caught by a customer report by adding a monitor, make sure to add that monitor. The more seriously you take this part of system maintenance, the more you will improve the experience for your teammates, support, and the end customer. Rule 6 is to capture esoteric fixes as descriptive code comments. Over my years, I've heard a school of thought preach that good code should be self-documenting. And I agree that this is something admirable to strive for, but inevitably there's going to come the need for that one weird trick or hack, especially in the realm of escape room software engineering. Without good contextual information located directly next to the esoteric code fix, it's easy for its reason to not be fully understood. Leaving the comment right there with the code also makes it so much more sticky. And I'd encourage others to be thorough. If you dug up how to handle some private API code from a forum post, feel free to leave a URL to it right there in the comment. And don't skim on PR descriptions. Please put lots of context so that if somebody digs up the commit that landed some change, all the details are right there. I think it is okay for code to look like this. If it's an eyesore for other programmers, there are IDE plugins that they can use to hide the code comments. Rule 7 is to keep your dependencies nimble and within LTS support. And what I mean by nimble is you don't want to be stuck in an incident scenario where you are pinned to some unsupported version of some library that prevents you from updating the dependency, which if you might be able to update it would help resolve the incident. Being blocked from easily migrating to newer SDKs or other library versions can introduce nasty side quests at unideal times. If you are dependent on packages or libraries owned by other internal teams within your org or company that fall victim to this pattern, flag the risk with them and your manager so that it can become prioritized. It will also make your life easier when you need to upgrade for vulnerabilities as well. If you trust that a package correctly follows semantic versioning, I'm a big fan of the carrot versioning and its equivalents in the other frameworks, where you can specify a minimum minor version that is allowed to then be updated to anything except a new major version. But with that said, don't just aggressively bump dependencies just for the sake of it, especially major versions. We had our version of Chromium bump due to the version in the Alpine APK package bumping without our knowledge once. And it turned out that the newer version of Chromium was returning shorter media segments from the tabs media stream than the previous version. And our recording library was struggling due to that. And it took a while to track down exactly what was happening, and the fix required updating that recording library. But since we can't control the APK version of Chromium, we set up a check in our Docker file to error if the major version of Chromium changed without our awareness. So this forced us to see the failure and then do a sanity check on that newer version as we bumped it to make sure that it worked before we released in production. The final rule is to design with resiliency in mind. Unfortunately, escape room software engineering there's going to be a good amount of works on my machine. Sometimes issues are intermittent. A single important lifecycle event or client action could fail once randomly out of 100 times, but would succeed if tried again. If it's a requirement for success of the workflow's journey, you should design your system so that it can handle these cases. In our case, we have what we call global retries and local retries. A global retry can be initiating cases such as the bot tried to load the video meeting page but hit a gateway timeout for that service, or the page crashed, or some other unexpected, unrecoverable error. In that case, the bot can ping our server with the error, and if it's retriable, it will increment a retry count and send another bot. And this will continue until the retries are exhausted. And then we also have local retries, which happen mid-journey, where we might expect some sort of latency where we're waiting on a user action, or we've identified some flaky behavior that has no better fix. In those cases, we make sure to wrap the logic that is idempotent, and then we can retry the behavior right there locally within the bot. So that concludes my journey into the world of escape room software engineering. I hope I've made a good pitch to avoid this type of engineering at all costs. But if you are forced to, that you understand some best practices to help improve the reliability of such a system. All right, thank you.
All right, I'm sure we have some questions for Justin. Anyone want to go first? Yep.
It seems like a pretty big software system to be running in this sort of way with third-party things. Do you think that what they're releasing with the APIs is going to sort of make everything smooth sailing with the media APIs from Google and Microsoft?
Yeah, we're expecting it to be a lot more reliable. We have the Google one in an internal beta state right now.
Wow.
And the quality is also much better. And one of the biggest perks is the way that we do speaker detection, because it's just a web client that we're recording, we have to look for identifiers on the page of who is speaking, and that's not always accurate, and there's like a lag to it. Because ultimately we're just getting one compressed media stream with all the speakers and video together.
Right.
But with the official APIs, we have access to the underlying streams themselves.
I see. So it can be broken up into individual users and things.
Yeah.
Yes. Right. Awesome. Do you have it must be difficult to make agreements with service reliability with this as well, because there's a lot of unknowns. You have problems with that? Like, do you guys have service level agreements with customers, or are you just like, you get the year for free because we dropped your video?
Yeah, we do. We have just like a couple high level ones, and that's where the breakdown of like failure versus cancellation is important.
Yeah.
But ultimately, like, it's going to include the gray area of like, we've had times where Zoom is just down, and then all of a sudden our error rate goes way up, but
it's definitely not your fault. Yeah,
it's we have to absorb that, and so we try to be really strict, but it's tricky for sure.
Did you go mental when you fixed that bug with Microsoft, when you found were you just like, yeah, boy?
Yeah, it was. Yeah, that one felt pretty good, but also it felt really bad because it's just not a fun.
Couldn't fix
it. Yeah, because the customers were really mad.
Yeah, I could imagine.
They're like, we recorded this important meeting and there's no audio, so it's worthless.
Yeah.
So it's good to like resolve it, but
yeah. Okay, so I can sort of relate with some of these things. That's cool. Thanks.
Yeah.
I just had a quick add-on to that. Like, my understanding was, WebRTC is supposed to be like a standard protocol that a lot of these services build off. Like, how come you need to use proprietary APIs from the providers rather than something like open like WebRTC?
Yeah, well, the Google one is actually based on WebRTC, and it's actually their official like API is not really polished. I would say it's still like in a developer preview release right now. And instead of like installing an official like npm package, it's just a repo that you clone with like a bunch of classes like structured that you're free to modify as you wish, which I think is just kind of like a version of what they're using, but they're starting to expose some of it for others to use.
But yeah, like in terms of the sort of WebRTC standard built into the browser, like is that not something you're able to hook into? Is that sort of too low level for what you're trying to do?
In terms of like if the browser version that we're doing.
No, just yeah, like capturing audio and video streams from WebRTC, I guess.
Yeah, well, that's how we're doing it with the new Google integration. Like we initialize the RTC communication layer, and then we're subscribed to the streams that are coming from it directly from it that way.
Awesome. All right. Any other questions? Yep, one all the way over there.
Hi, my name is Kaustav. I'm a developer at Walk the Dragon. So currently we use Playwright for E2Es, like to protect basically our critical paths from regression on the main branch. So would you say escape room programming is basically running the E2Es with modifications for our specific case? And if so, it would still spin up an particular instance of Chromium or Safari. How do you get across the problem of works on my system? And have you had success using other tools other than Playwright, example Cypress, for for escape room testing?
Could you repeat the Chromium versus Safari? Could you say that again?
Like Playwright or Cypress, any E2E tool would spin up a particular instance of the browser, I believe, on our local, wherever we are running the E2E. So that particular version might have some compatibility issues with whatever APIs it's using. How do you get across the issue of something working on a particular version of the instance it's spinning up, as opposed to like working everywhere?
Yeah, it's tricky. I think it's good to stay up to date with Chromium. Like what we ran into issues for a long time, we were pinned to like an older version, like 139 or something. And they're pretty aggressive on how they push out updates on these platforms. So if it's like a year and a half behind, that's like when we started running it. One day, like Zoom just completely stopped working, and we never actually figured out exactly what happened, why, but we think it was due to the way that we did. Like they were serving WASM WebAssembly modules from their server remotely, and they changed how those worked, and our old version of Chrome couldn't handle that. So I think it's good to stay up to date with those, but we do run into issues because due to how like Atlassian monitors like the networking on our computers, we couldn't use Chromium. I forget exactly, like we couldn't use the like the remote debugging port for that, but we could if we use Chrome for testing. So we have like a dual test scenario where we can use Chrome for testing locally, but then once we build the containers, it's Chromium. And sometimes we do notice some differences between those, which is tricky. But yeah, we try to just stay up to date and try to stick with Chromium, which is like the most common supported. I know there are newer ones. We can't run it headlessly. We have to run it with a head because we need to actually render with a window that we can capture the stream of. So we're a little limited that way too, because I know there are newer emulating libraries that run headlessly, but we just can't use them.
Got it. Thank you.
Yeah.
All right. One more question. Anybody else? No worries. All right. Thank you so much, Justin.
Thanks.